Our daily life depends more and more on the advantages of information and communication technologies. Information and communication is available anywhere, anytime, with any content for any user using any device and any access. No doubt, we are entering the era of ubiquitous computing, where computers are becoming smaller, more powerful, invisible and permanently networked. But in our factories, the old traditions are still hold. A lot of paperwork, many cables and traditional interaction devices. But as modern ICT technologies are penetrating our homes and lives, they will penetrate our factories in future as well. In 2004, a group of German companies and researchers met to discuss the impact of these technologies on future factories. As a result, the idea of the smart factory was conceived and made reality. A key characteristic of this new kind of factory is its agility in both planning and production. To this end, it should make extensive use of advances in the field of cyber-physical systems. The factory, built in 2005 and 2006, is based on a real production setting in a downsized but representative factory environment. Therefore, the equipment is divided into a batch process part and a bottling line. The overall goal was to create a vendor-neutral demonstration and research testbed where modern ICT techniques can be examined under realistic conditions. This factory should then be more agile in planning and operation to meet the demands for shorter product life cycles and more product variants. The human operator should not be replaced by technology, but be optimally supported in his work by these technologies. Since then, the Factory of the Future has been established and, as intended, it is a visionary demonstration and research platform. Such a large-scale, real-life production process is the perfect testbed for new methods, concepts and technologies in and for the industrial field. At each step of the bottling process, that is for the filling and handling the soap bottles, we have developed a variety of new techniques, such as tagging the product with an RFID chip which contains all relevant order and product data. In this way, the product keeps its own memory. Smart product memories will control their environment using machine-to-machine communication in order to enhance the effectiveness of the production process in a proactive manner. As in real factories, the smart factory also contains a central control desk where all processes can be monitored. From the first ideas, this factory should make intensive use of all so-called ubiquitous technologies already to be found in our daily life. To ease planning and shorten planning times, advances in digital factory tools should be used. This could be realized by changing modules quickly, if for instance a new demand for scented soap comes from the client. If you could switch easily between real-world applications and their virtual reality counterpart, as in computer games, new possibilities in planning, handling and support would arise. The core functionalities of the cyber-physical systems, such as monitoring and control of engineering systems, computing and communication, are embedded in products and equipment. This forms the common ground to create a new level of interoperability and interconnectivity between the virtual and the real world. Wireless technologies will also help to improve agility. When no cables have to be planned and installed, no time will have to be spent on this task. But the industrial domain will impose much higher requirements for safety and security of wireless solutions. A successful implementation of wireless networks will also require a comprehensive planning of the radio band use. Indeed, RFID technology is already being used in industry, but today's strict identification solutions should be further developed to smart product memories, where the product maintains comprehensive information on its own production, its properties, its use and disposal during the complete life cycle. This can also be used to control the production steps in worldwide networks. Smartphones are playing an ever more important role in our daily life. They are very powerful small computers which offer strong networking functions in local as well as in global networks. So we should also see how they can be put to good use in our factories. In the smart factories, smartphones are used as universal interaction devices. They can be used to check and change parameters, to support maintenance actions and even to control the processes. Cables give us implicit information about the place of interaction. When switching to wireless technologies, we need to get this location information by other means. This is very important when talking about human interaction because this is often dependent on a specific context. An example for an actual indoor positioning system is a tool and gear wagon which is equipped with an RFID reader. This device reads tags in the floor which supply information about location and the direction of movement. In the past, sensors and actors used analog control signals to communicate. With the introduction of microprocessor technology, we have switched to digital bus interfaces which can transfer more complex control information. In future, these devices will become smart. That is to say, they will offer web server functionalities and will be able to operate as smart objects in wired or wireless IP networks like the Internet. We will not talk about signals supplied by wires anymore, but of services the devices offer. When these devices are becoming smart, they can operate as smart objects in a network. These objects have a standardized model representation and will offer services via the network. This will lead us to service-oriented control architectures on which today's ERP systems are based already. Smart objects will also have an effect on the control architectures. Today's control pyramid, which is characterized by a strictly hierarchical structure with horizontal integration within the established ERP, MES and device levels, will be replaced by a network architecture with distinct vertical integration over all levels. As we have learned from the consumer world, networks, in particular when they are based on open standards, require special attention with respect to safety and security. That means assuring the availability and integrity of the network at all times. We must also prevent the network from intrusion and from any form of malware, be it from amateur script kiddies or criminal competitors. Industrial applications will require extremely high standards in these areas to gain the necessary trust of the customer. The Smart Factory in Kaiserslautern is a perfect example for an innovative testbed demonstrating the advantages of modern information and communication technology like we highly appreciate in our daily life. In this worldwide unique research and demonstration center, innovative technologies can be tested for their impact, suitability and usability in industry. Following the paradigm of the Internet of Things, the Smart Factory guides us to a new vision, the Factory of Things.